Hello everyone, you are welcome to today's lesson. And in today's lesson, we are going to continue from where we left off. Okay, and we are looking at simultaneous equations in two variables. Simultaneous equations in two variables. In our previous lesson, which was lesson 2, we looked at how to solve the various techniques, okay, and we perfected our techniques in solving equations simultaneously, be it the elimination method or the substitution method. So we dealt with more examples in order to make our understanding what's better. Today is not going to be an exception. So the lesson 3 is not going to be an exception. We'll be looking at more questions, and in our quest in getting the solution to the questions, I will be giving you vital information that you will need to be able to present your solution maturely and ideally. Okay, so stick and stay with me whilst I take you through that. Okay, so quickly, let's look at our fourth question. So find the true set of the following simultaneous equations. So remember, I've told you anytime you read questions, make it a habit to underline the salient part. So here, the salient part is what? True set. Okay, then after that, what do we do? Okay, after we've underlined the salient part, we come and write solution. The questions are numbered, so it means your solution equally must be numbered precisely. So we have a major number, question number 4. Okay, then we have a minor question number A, and that's what we are looking at. So in the first question, the A, we are given 2 equations. So as usual, we extract the equations and label them either directly or manipulate before we label, depending on the nature. So here we are given 5x, okay, plus 3y, okay, is equal to 9. Okay, this equation, no fractions, no brackets. Okay, it cannot be reduced. Variables on one side, constant on the other side. So it's of the form that we want. So it will be equation 1. Okay, so, and, okay, we go and extract the second equation, and that is minus 2x, okay, plus y, okay, is equal to negative what? 8. Okay, so per my plan, usually, and this is the advice, okay, if you are moving alphabetically, make sure, if possible, your leading coefficient is positive. So here, our leading coefficient, which is the coefficient of the first term there, numerical coefficient is negative. So if you like, you can make it positive, so it's like you are manipulating. You make it positive before you label, or again, I can label. So I will call this equation 2. However, now I'm mature, so I'm not going to do the labeling straight away from there. This is exactly what I am going to do. Okay, I know studying the 2 equations, the first equation, okay, and the second equation that I have here, I can see that if I label this equation 2 and I want to use elimination, I cannot easily eliminate. Okay, if I want to eliminate x, I have to multiply equation 1 by 2 and equation 2 by 5 so that I can add to eliminate. If I want to eliminate y, I have to multiply equation 2, provided I've labeled this equation 2 by what? By 3. So it means even with the elimination, okay, it is better to eliminate what? Y. Because if you want to eliminate y, it's only one equation that you multiply by a constant. However, I'm not going to go the elimination route. So what I will do is, okay, so this equation, before I label it, I want to make y the subject, because elimination, I have to multiply at least one of the equations by a constant. So for the substitution, I can make y the subject here without involving a fraction. So I will move on and come and write. This implies that, okay, make y the subject before labeling the equation. So I'll get y is equal to, then I move this one here. This will be positive, this will be negative. So it will be minus 8 plus 2x, but it is better you write a positive term first. So it will be 2x minus 8. Then you call this equation 2. Is my point well made? My professors, are you following?
Yes, sir.
Okay, so at this point, you knew before you did this that you were going to use the substitution method. So you write equation 2 into, okay, equation what? Equation 1. If you decided to label this equation 2 and you are going to do this, then you have to write from 2 before you come and you call this 2a. Okay, so, but that would be more work. Okay, so at this point, wherever I see y in equation 1, it becomes 2x minus 8. So I'm going to get 5x, okay, plus y. Sorry, 3y. So 3, your y is what? 2x minus 8. Okay, and that is equal to 9. Okay, so at this point, what do? I'm going to get 5x, come and expand this plus, okay, 6x, okay, minus, okay, so this will give us 24, okay, is equal to 9. My professors, I hope you are following.
Yes, sir.
Okay, so I'm going to get this plus this, which will give me 11x. Okay, and that should be equal to 9 plus 24, and that will give us 33. I write it again before I divide. So I will get x to be equal to 3. Now I will need x to find my y. So I will label this as equation 3. Go and substitute 3 into equation 2, the one that I made y the subject. So equation 3 into equation 2. Okay, and that gives you y is equal to 2, your x is 3 now, okay, minus 8. So that will give you y to be equal to 6 minus 8, which gives you y to be equal to negative 2. So at this point, because you were asked to find the solution set, okay, you can't draw your conclusion by saying, therefore, x is equal to 3 and y is equal to negative 2. Remember. Okay, so now what do we have? True set. Therefore, you come and write x comma y is equal to, did I say is equal to? Forgive me. It's such that, okay, so take note of that. It's such that usually if it's one variable and you solve, maybe you are finding the true set will be x is such that x is equal to, you state its value. Okay, if it is x and y, two variables, it will be x comma y is such that, then you come and write the x, state its value, comma y, state its value. Or you can come and write x and y is such that, and end is the same as the comma. Remember, I've told you in maths, we can use comma and end, okay, interchangeably to mean the same thing. So what do we have? It's like that x will be equal to, state the x value, 3, and okay, y is equal to, or I said instead of the end, you can use comma, y is equal to what? Negative 2. You close your curly bracket. Okay, so this will be the ideal solution for this particular question. So we are going to do one more. It's basically because of the conclusion. Okay, how you would conclude. Otherwise, this question, you should all be able to deal with it. So I'm going to do the B with you, or we are going to do the B together. Then after that, okay, we'll move on to the next question. So B, what are we giving? We are giving, okay, 2a minus 3b is equal to 4. Okay, no brackets, no fractions, equation cannot be reduced, and we have everything on, the variables on one side and the constant on the other side, the form that we want. So we'll label this as equation 1. And we go to the second one, which is 3a, okay, plus 2b is equal to 19. And that one too has the same property. Variables on one side, okay, then the constant on the other side cannot be reduced, no fraction, no bracket. So you call this equation what? Equation 2. And here I'm going to call this equation 2 because studying this equation and this one, okay, if I want to eliminate, Okay, obviously I have to multiply at least one of the equation by a constant. If I want to use substitution too, I cannot avoid using what yes, fraction. So I will label this one. So the two method, none of them will be convenient to use. Okay, so at this point, you are at liberty to go for the one that you want to go for. However, I am going to go for the elimination. Okay, I'm going to go for elimination. Okay, all right. So if I want to eliminate, let me go for, okay, I want to eliminate B. If I want to eliminate B, I have to make sure that the coefficients are the same. So I will go for the lowest common multiple, and that will be 6. So that means that I need to make this one 6, and I have to multiply it by 2. Okay, so I'll multiply each of the 10s by 2. Then if this must be 6, this also must be multiplied by 3. So I will go and write equation 1, okay, times what? 2, comma, then it means each term times 2. So that will give me 4a, okay, minus 6b, okay, is equal to what? 8. Okay, so that becomes my equation 1a. Okay, then we go to equation what? Equation 2. Okay, so equation 2, to remember the plan is to eliminate the b. So the coefficient, remember we said we multiply this one by 3. So it will be equation 2, okay, times what? Times 3. Okay, and that gives us what? We are going to get, so we get 3a times 3, and that will give us 9a. Okay, then we will get 2b times 3, and that will give us 6b. That will be equal to 19 times 3, and that will give us 57. Am I right? Okay, so in effect, we are going to also call this one equation 2a. Okay, so we are going to work on 2a and 1a. So we said we are eliminating. So let me write the 6 well. So coefficients here, negative plus, the signs are not the same. So they are opposite. So we have to add to eliminate. So it will be equation 1a plus equation 2a, comma. So 4a plus 9a, and that will give us 13a. That should be equal to, okay, we are going to get, this will go anyway, so that will be eliminated. So we are going to get 57, okay, plus 8, and that will give us 65. Am I right? Hello, am I right? Okay, so that will give us this value that we have here. Okay, so now we write it again before we divide. Okay, so we write it again before we divide. 13a is equal to, okay, 65. Okay, over 13 over 13. So we are going to get what? A is equal to, okay, 65 over 13 will give us 5. Am I right? So A will be equal to 5. So you label this as equation. Okay, we've done 1. Okay, so 3. Then you go and write equation 3 into either the original equations or the transformed equation. But because you multiplied your original equation by a constant, your transformed equation will always be a bigger equation. So you go and use the original equation. So I will go for equation 1. So equation 3 into, okay, equation 1. Okay, comma. So that will give us 2a. So it will be 2 into a, which is 5 now. Okay, minus 3. Okay, b. And b is what? We don't know. And that's equal to what? 4. So in effect, we are going to get 10, okay, minus 3b is equal to what? 4. So remember, we have to, this is negative. You can keep it here and divide by negative. I always want to avoid that. So I'd rather move and come and get 10 minus 4, and that will give me 6. It's equal to 3b. I'll write it again before I divide. So 3b is equal to 6 over 3 over 3. So I will get my b to be equal to what? 2. So at this point, I can comfortably come and draw my conclusion. So I'm drawing my conclusion here. Therefore, okay, curly bracket, remember it's true set. So I'll write a comma b is such that a is equal to the value 5, comma, remember I said it's either you use and or comma. Okay, b is equal to what? 2. Then you close it. Is my point well made, my professors?
Yes, sir.
Okay. Prof. Mamisa, are you there? Can you hear me? Mamisa, please, can you hear me? Okay. All right. So at this point, we are going to move on to the next, okay, question or set of questions. So the rest you will deal with it. The space here is for the rest of what the questions. So you can, okay, make use of the space when you, if you're able to print and you want to put the solution there. Okay, so quickly let's go and look at what that of what question 5. Okay, question 5. You can see that the equations are not pretty at all. They contain fractions. Okay, don't worry. We know equations of this nature and how to deal with them. Okay, so quickly, let's go and look at what the solution to question 5. So let's see. Let's read the question and underline the salient parts, if any. So find the solution set. So here, obviously, solution set, okay, must be an of the following simultaneous equation. So you come and write solution, question number 5a. You extract, what are we given? We are given, okay, 4 on 3a, okay, plus 5 on 6b is equal to what? 1. Okay, so at this point, remember, we need to clear the fraction. I said before we label our equation, let's make the equation pretty. So you have to do, okay, pedicure and manicure, a letter. Okay, so in this case, we have to clear the fraction. Okay, and in clearing the fraction, we have to multiply through by the LCM. So the LCM here will be what? 6. Okay, so once the LCM is 6, what do? We multiply each of the terms by 6, which is the same as multiply through by 6. So this 1 times 6, I'm doing that mentally. The 3 will go here too. So it will be 2 times 8, then times a. So I'll write, this implies that, okay, 8a, because it will be 2 times 4 times a, which is 8a, plus this 1 times 6, the 6 will cancel. So I'm going to get what? 5b is equal to this 1 times 6 will give me 6. So it's then that I come and call this equation what? 1. And I go for my second equation. The second equation is 1 over 3, okay, a minus 5 on 12 b is equal to what? 3 on what? On 2. So again, we cannot label that. We have to avoid. Okay, I mean, we shouldn't. You can if you want to, but you shouldn't because of the advice. Okay, make sure your equation is pretty in the sense that it will not contain fractions, brackets. If you can reduce, you reduce before you label it. Here it contains fractions, so it's not pretty. Okay, so we go and multiply through by the LCM. 3, 12, 2, so that will be 12. So we multiply through by 12, each of the terms by 12. Okay, so this implies that, okay, this times 12, 3 will go into the 12 4 times a, so I will get 4a. Okay, then minus this 1 times 12, so I will get 5b is equal to this 1 times 12, 2 will go into the 12 6 times 3, and that will give me 18. So that gives me equation 2. So my original equations were these two equations. The transform version of the first one is this. The transform version of the second one is this. So I label. Okay, at this point you can see, because you cleared the fraction, you can see that you can easily eliminate b. So we'll go for the elimination method because we don't have to multiply any of the equations, okay, by anything if you want to eliminate what's the b. However, if you want to eliminate a, you have to multiply this one by 2. Okay, so on that note, sign here is plus. This is minus. Okay, so I need to add to eliminate. So it will be equation 1 plus what? Equation 2. Okay, and that will give me 8a plus 4a, and that will give us 12a. That should be equal to, okay, plus 5b minus 5b. So it will be this plus that. Okay, so that will go. Okay, that was your intention anyway. Then you get 6 plus what? 18, and that will give us what? 24. Okay, so you write it again before you divide. Okay, it's equal to 24. Okay, over 12, over 12. Okay, so a will be equal to what? 2. Then you need a to find your b, so you call this equation 3. Okay, so you go and substitute the equation what 3 into the pretty equations, not the ugly ones, the original ones. Okay, so here, which one do we go for? I will go for equation 1. So 3 into, okay, into equation 1, comma, and that will give us 8a. So 8 into a, and a is what? Is 2. Okay, plus 5b is equal to what? Your 6. So it will give 8 times 2 will give us what? 16 plus what? 5b is equal to what? 6. So you move this one to the side. That will give you 5b is equal to 6 minus 16, and that will give us minus 10. You write it again before you divide. So you get my 5b is equal to minus 10 over 5 over 5. So you get b to be equal to minus 2. At this point, remember, you were asked to find the solution set, so you knew that your conclusion will be in the true set form. However, maybe if you concluded by saying therefore, then you wrote a is equal to this, b is equal to this. Remember, that's the more reason why you underline. I've told you that you don't just underline. You underline in such a way that before you move on to the next question, you subject your final answer through what you have underlined, or you subject your work through what you have underlined. So if you concluded by saying therefore a is equal to 2 and b is equal to negative 2, okay, you have a second cure. Let me see whether it means, okay, solution set. So it means I have to go and clear my therefore, okay, and come and write the therefore again and state it in the true set form. So that will give me a comma b, okay, is such that a is equal to its value, which is what? 2, and okay, or comma b is equal to what? Negative 2. Okay, I guess my point is well made.
Yes, sir.
Okay, very good. Okay, so we are going to do this particular one. Okay, the one that we have here. If you're able to do the B, okay, the rest of the questions, okay, you should be able to do it. So quickly, let's go and look at. So you can see that all along your variable. So you let me pick it, then I will make that same statement in my explanation. So B, what are we giving? We are giving 1 over s, okay, plus 1 over t, okay, is equal to what? 5. All right. Okay, so let's see. Unlike all the equations that we've dealt with where it contained what? Fractions, you realize that the fraction, okay, the denominators were numbers, they were not letters. So all along, you can see here your letters were numerator letters. Now you have your letter to be a denominator. So how do you deal with situations, okay, like this? And it shouldn't be a problem at all. Okay, so let's see what we are going to do. Very soon you will mature and you will know how to deal with it, okay, matured way. So I will label this as my equation 1. no issues. This one is not the normal one that we said, clear the fractions. But here, because the denominator is not a constant, okay, it is better you leave it like this and label it. If you had s over 2, then maybe t over 3, okay, then we would have cleared the fraction. Hello? Okay, I guess you are with me. Okay, my network got disconnected. Okay, so I think we have resumed. Okay, so we can continue. Sorry for that H. So I was saying that here it's not the usual situation where the denominators will be numbers you clear. So let's go and look at the second one. So and if you like, if your n can go here, you continue. Otherwise, you come down. You can even ignore the n, comma, then continue. You can use comma. Remember, comma we said is the same as what your n. So what do we do? The second one is what? 1 over t. Okay, minus 1 over s. Okay, is equal to what? 1. Okay, so please take note. This question is so interesting. So you can see me smiling, or you can feel me smiling. Okay, all right. So this is what we have. Okay, so I will label this one also as equation 2. Okay, we have two ways of dealing with this question. Okay, one is to make a substitution for the 1 over s and the 1 over t. So maybe you can say 1 over s be equal to a, 1 over t be equal to b. So that this will give you a plus b. Then this will give you b minus a. Okay, then you work with it. But because you made that substitution, okay, you cannot conclude with the a and b, because if you solve, you get your answers in a and b, and you have to go back. Okay, maybe I'll walk you through that method too. Okay, but for now, this is what I want you to see. If you look at this critically, you can see that to the left-hand side of this equation, the first equation, and the right-hand side, they are like terms. One is 1 over s, okay, and you have 1 over t also here. So it means you can combine. I can eliminate the s by adding equation 1 and 2, because 1 over s plus minus 1 over s, okay, will vanish. Okay, the s will vanish, so I'll be left with only t. Is my point well made? Should I come again?
Yes, sir.
I should come again, or my point is well made?
Sir, please come again.
Okay, all right. So I was saying, you can see that 1 over s and 1 over s, they are like terms. Can you see? It's just like,
Yes,
and the same way, 1 over t and 1 over t are like terms. So I can combine them. So in this case, I can say, because I can see 1 over s here and 1 over s also here, 1 over t, 1 over t, they are like terms, though they are not arranged the same way. So I could have written this one as minus 1 over s plus 1 over t, or this one as 1 over t, okay, plus 1 over s, so that your 1 over t term will be the first term here, 1 over s term will be the second term. You can see that the first equation, 1 over s is the first term, 1 over t is the second term, but the second equation is the swap. But don't let that confuse you. It's the same thing. It's like me giving you a plus b is equal to 1, and maybe b minus a is equal to 2. Okay, you know that this is the same as a minus a plus b is equal to 2. If you want the first term to be the same, the like terms, and the second terms to be the same, you can always, okay, swap your terms. Okay, using without defining any mathematical principle. But I'm not going to swap. I know when I'm adding, I will add like terms. So I'll go and write equation 1 plus equation 2, comma. So equation 1, I'm going to get 1 over s will come and add what? So I will add the like terms. You say this and this, then this and that. Okay, all right. So 1 over s plus minus 1 over s, 1 over s will go. Then I'm going to get 1 over t plus 1 over t. A plus A will give you what? A plus A is what?
This question.
A plus A, what would that give you? A plus A.
2A, sir.
2A, very good. So 1 over T, so it's like a quantity plus itself, the same quantity, will give you twice the quantity. So 1 plus T, okay, plus 1, sorry, 1 over T plus 1 over T will give us 2 1 over T. Am I right?
Yes, sir.
Okay, so I can see that this is the same as 2 over T, which is the same as 2 times 1 over T is 2 over T. You get it?
Yes, sir.
Okay, and that should be equal to, you come and add the side, so 5 plus 5, and that will give you what? Sorry, 5 plus 1, forgive me, that will give you 6. So at this point, you have an equation in T. You cross multiply and solve for your T. So if you cross multiply, we are going to get what? 6T is equal to 2. So I will get 6T is equal to 2, but I'm looking for T. So I write it again before dividing. So over 6 over 6. So I will get T to be equal to, I can reduce 1 over 3. Is my point well made?
Yes, sir.
Okay, so once I know T, I can go and find what? My S by substituting just like the usual one. So I will call this equation 3. And go and substitute equation 3 into any of the two equations, but I will go for equation 1 because I want to avoid negative. However, if you can deal with the negative, you can come and substitute that into equation 2. So I'll move on to the next one, which gives me equation 3 into, okay, equation 1, comma. So let's go back and see. So that will give us 1 over S plus 1 over T is equal, but T is 1 over 3. So we are going to 1 over S plus 1 over T, but T is 1 over 3. Okay, and that should be equal to what? 5. Okay, hope I'm right. Okay, so that's equal to 5. So at this point, you can see 1 over S, so you come and write 1 over S, okay, plus, this is the same as 1. You can use your calculator to do this. It's the same as 1 divided by 1 over 3, which is 1 times, okay, 3. You get it? It will be 3 over 1. So what I have there will give me 3, and that is equal to 5. You can use your calculator to do this if you can't do that mentally. So now what do? You get 1 over S, okay, will be equal to 5 minus 3, so that is 2. So again, you cross multiply, and that gives you 2S is equal to what? 1. So you write it again before you divide, okay, over 2 over 2. So we are going to get S to be equal to 1 over 2. So we know the values of X and what? And T. So you go and draw your conclusion. Therefore, you're asked to find the true set. So it will be S, comma, T is such that S is equal to 1 over 2 and or comma T is equal to what? 1 over 3. You are done. You close it. Point well made, my professors. Hello, I hope you are following, my professors.
Yes, sir.
Okay, very good. Okay, so on that note, so you know how to deal with a situation where your variable is in the denominator or your letters are in the denominator. So take notes. So if maybe I'm just writing, I told you that I will give you another method, but okay, let me see if maybe we can play with that method too. Okay, so that the one that sits well with you, you deal with it. But that method, it comes with a risk. Okay, and I will tell you when we get there anyway. So let me quickly walk you through that. So alternative approach. Okay, again, what are we giving? We are extracting our equation 1 over S okay, plus 1 over t is equal to 5. Okay, so I will call this one equation 1. Okay, then, and your second equation, what do we have? Okay, 1 over t minus 1 over s is equal to 1. So this becomes equation 2. Okay, so now this is what we are going to do. We will let, okay, a be equal to 1 over s and b be equal to 1 over t. Okay, you can write let s be equal to 1 over s, then y be equal to any letters, okay, different from these two letters. Okay, so this implies that your equation 1 will be 1 over s, but you said 1 over s is a. So you get a, okay, plus 1 over t is b. B is equal to 5. So I will call this maybe, okay, equation 1, the same equation 1. Okay, let me write this maybe equation 1a. Okay, all right, then, okay, equation 2 will give us 1 over t is b, so b minus 1 over s is what? Is a. Okay, it's equal to 1, so this becomes maybe your equation 2a. Is my point well made? My professors, are you following? Okay, so at this point, you are good to go. So let's see. You can see that you can eliminate what? A by adding. You can eliminate B by subtracting because the coefficients are the same. A, the coefficients are different in terms of signs. So I'm going to write equation 1A, okay, plus equation 2A. So that gives me this a plus minus a. The a will go. Then I'll get b plus b. That will give me 2b. Is equal to what? 5 plus 1. That is 6. Okay, so I'm going to get 2b is equal to 6. Okay, then over 2 over 2. Okay, so that gives me b to be equal to what? 3. Okay, I will go and solve for A. Then later I will come and substitute because I cannot conclude with A and B. I will go and substitute the corresponding. So I will call this equation 3. I will need 3 to find, okay, my A. So let me write the B well. So I will go and write equation 3 into, okay, which of the equation? I will go for equation, okay, 2a. Or let me even go for equation 1a. Obviously, I want to avoid negative, my negative that I don't like. But that doesn't mean you can't go for equation 2a. So equation 1a. Okay, so the comma, and that will give you a plus 3. Oops, 3, then I wrote b. A plus 3 is equal to, okay, 5. So A will be equal to 3, 5 minus 3, which is equal to 2. Okay, but unfortunately, you can't say that, therefore, A is equal to 2, B is equal to. A and B came by way of your own introduction. So in math, you don't conclude with what you introduce. So this is what we are going to do. Let me see whether I have another room. Okay, this is a new question. So what I'm going to do is I'm going to create, okay, another slide, okay, for this. So let me pause recording and okay, so at this point, just as I was saying, you realize that your A and B found, but you cannot conclude with A and what? And B. Okay, so we have to go and substitute, okay, that back into this and solve for our A and sorry, S and what? And T. Okay, so I am going to write something just to, so I'll write but, okay, so but you stated that A is equal to 1 over what? S. Okay, so this implies that, okay, this implies that A gave us which value? Quickly, let me go back and check. A gave us 2. So this implies that 2 is equal to 1 over S. So if you do that, we are cross multiply, you get 2S is equal to 1. So 2S is equal to 1 over 2 over 2. So it means your S will be equal to 1 over 2. And you also stated that, okay, B is equal to 1 over T. So this implies that your B gave us what? 3, and that will be equal to 1 over T. So you are going to get 3T is equal to 1 over what? Or is equal to 1, forgive me. Okay, then you go and write it again, then you divide. So 3T, okay, will be equal to 1 over 3 over 3. So T will be equal to 1 over 3. So now what do? We I can see that we had the same values for the reason why I said it's risky is that if you don't take care with this one, if you don't take care, you might conclude with the A and B. Okay, so that's the only disadvantage. If you don't take care, your equation is in S and T, so your answer, your conclusion must also involve the same letters. So please take notes. Let me write the A well. So at this point, you go and draw the same conclusion that we had drawn here. So it will be therefore, okay, your S comma T, okay, such that S is equal to, okay, 1 over 2, and, okay, T is equal to what? 1 over 3. Then you close it. Or you can use comma here. Okay, like I said. So that will be it for this question. Okay, so let's look at, okay, the next set of questions. Okay, so this one too, I believe you should be able to deal with it. Okay, you should be able to deal with it. We have linear, okay, and quadratic products. We've done questions of this nature, okay, in the previous lesson. The main, okay, or the important information here is the solution set, so that you don't conclude in the normal form, but in the solution or the true set form, in the set form. Okay, so I will skip this one, okay, as well, because you should be able to deal with it. Then we come to question 8. Okay, question number 8. Okay, question 8, similar to what we have done, only that I'm going to give you some basic information not to stress yourself. The question is different. If you don't take care, okay, you might go and stress yourself unnecessarily. So this is it. All right. So as usual, when you are asked to find the value of x, so here we need only the value of x. Okay, so solution, what do we write? Major question number A, minor question, so 8, minor question number A. You extract your equation giving, and what are we giving? X minus y is equal to what? 2. And, oh, sorry, I need to label this equation. What am I in a hurry for? All right, so in the form that I want, okay, variables on one side, constant on the other side, no fraction, no bracket, so equation 1. And, okay, my second equation, 3x plus y is equal to 1. Variables on one side, constant on the other side. Okay, I can easily eliminate, so I won't go on to make y the subject before I label. Okay, so I'll go my usual route. However, okay, so here, listen, and listen carefully. Okay, if you don't take care, you will go and solve for x and y and conclude with only x, which is allowed. Okay, but you waste your time. Okay, we are looking for only the value of x, so we don't need the value of y. So don't stress yourself looking for the value of y. And in simultaneous equation, you can find the value of any of your variable of interest first. So if I want to find the value of x, if I want to use substitution, okay, let me deal with elimination first. If I want to use elimination, then it means I have to eliminate y. so that my resultant equation will be in terms of x, then I solve and get s straight away without going to or involving the y value. I guess my point is well made. Okay, so if that is the case, then this is what we are going to do. So let me also talk about the substitution. If you want to use the substitution and you are looking for x, it means you have to make y the subject. So if you were looking for x, okay, elimination, you eliminate y. Substitution, you make y the subject. If you are looking for y, elimination, you eliminate x. Substitution, okay, you make x the subject and what, and substitute what, y. So you should know these tricks before you go and stress yourself. So at this point, what do I do? Okay, I can use elimination to eliminate y, and so I'm good to go. So with this one, I am going to write equation 1, okay, plus equation 2. Okay, so the variable that I can easily eliminate is the one that I should eliminate to find my y. So I thank God. So that will give me x plus 3x. That will give me 4x. Okay, then I am going to get what? Y minus y plus y. And that will give me 0. My elimination, I've eliminated. Then 2 plus 1, that will give me 3. So it's equal to 3. So I write it again before dividing. So you can see that now I have my equation in x. So it means if I solve, I will get x straight away. Okay, so I draw my conclusion. Therefore, x is equal to what? 3 on 4. I was asked to find x. I'm done. Somebody who is not privy to this will find x. Maybe it's possible. Go and find x. Then go and find y. Or you even proceed after finding s. You proceed to find y. But we are not interested in the value of y. Okay, so after finding your s, you get stuck. You stop there, not that you get stuck. You are supposed to stop there and draw your conclusion as such. Okay. All right. So in the same way, let me look at, okay, that's of what? So the alternative approach. So let me go for the alternative approach, which is the substitution approach. So that one too, you are given, okay, x minus y is equal to 2, equation 1. And, okay, you come to 3x plus y is equal to 1. I won't label this because I want to use substitution. I want to make this the variable, okay, or yes, I want to make this the subject, okay, before I label. So I'm going to write, this implies that y is equal to 1 minus 3x. So that becomes my equation 2. Or you can label it and come and write from 1, make y the subject, okay, or from 2, make y the subject. Because you are looking for x, okay, you make y the subject, which will be in terms of x, then you go and substitute. Then you find x straight away. So I'll go and write equation 2 into, okay, equation what? 1. Okay, so that gives me x minus my y. X minus my y. Yes, my y, I put it in brackets, more than a term, and the sign, okay, before it is negative, is equal to 2. So I'll end up getting x minus 1 plus 3x is equal to 2, which ends up giving us s plus x, which is 4x, is equal to 2 plus 1, which is 3. Okay, remember. So at this point, you can see that we are virtually going to land at the same answer because we have the same equation, okay, here. So that will give us what? 4x is equal to 3 again over 4 over 4. So that gives you s is equal to what? So you draw your conclusion. Therefore, s is equal to 3 on what? On 4. As simple as that. But obviously, you can see that this is ideal. So look at, okay, the volume of work here and the volume of work, okay, at this point. So that will be it for situations like this. Okay, so on that note, so with this one too, okay, you can see with this one, okay, or let me deal with the B and guide you, okay, to do the rest of the question. So B, Okay, what do I have? I've been given, okay, x plus y is equal to minus 2. Okay, so equation 1. And my second equation is what? X plus what? 6y is equal to 3. Okay, equation 2. Okay, so now let me see. Okay, I've been asked to find the value of x. So it means if I want to use elimination, I should eliminate y. But if I'm eliminating y, I have to multiply equation 1 by 6. The coefficient must be the same. Then I subtract. Okay, let me see whether substitution will go. If I want to use substitution, I have to make y the subject. Do I have any of the equation that if I make y the subject, okay, it will not involve a fraction? Yes, and that will be equation 1. So I will rather go for the substitution method instead of elimination. So I'll write from equation 1. Okay, if you like, you can still go for the elimination. I've told you that I usually like elimination. I would have eliminated anyway by multiplying this one by 6. Okay, so that gives us, what do we have here? We are going to get from 1, we are making y the subject. Remember, we need to find x, so you make y the subject. So y will be equal to minus 2 minus x, or minus x, or you let me write minus 2 minus x. I always want to write so in this case, I will call this equation 1a. So equation 1a into, okay, which one? And let's go for, remember, once you made it the subject in equation 1, you have to substitute that straight into equation 2. Okay, so that gives us x, okay, plus 6 into your y. And your y is what? Minus 2 minus x. And that should be equal to 3. So you get x. Okay, you come and remove the bracket. To be 6 times negative 2. So it will be negative 12. Then 6 times negative x. So that will give us negative 6x. And that should be equal to what? 3. So at this point, you get x minus 6x, and that will give you minus 5x. And that should be equal to 3 plus 12, and that will give you 9. I hope you are with me. Hey, did I say 9? 15, forgive me. It will be 3 plus. So it will give you 15 rather, not 9. So be careful. Okay, so that will give us what? 15. You write it again before you divide. Okay. Over negative 5 over negative 5. So I will get, therefore, my x is equal to negative what? 3. Okay, I'm done. Okay, I don't need to go and find the value of y unless you don't understand, okay, exactly what, or you don't get exactly what I have, okay, advised you or instructed you to do in such a situation. Okay, so this will be it for this particular, okay, situation or question. Let me give you about 3 minutes or 4 minutes water break. When we come back, then we come and continue. Okay, so welcome back from the water break. Now we are looking at what? The solution to question, okay, 9. Question 9, what are we supposed to do? We are supposed to find the value of y. Okay, so as usual, okay, because we are not asked to solve straight away, okay, like the usual, find the x and the y. Okay, you underline, find the value of y. And I've told you already that in math, anytime you are asked to find the value of a variable, don't conclude by saying, therefore, the value of y is this. Just write, therefore, y is equal to, then state its value. As simple as that. Okay, so here, since we are asked to find the value of y, okay, so let's see. This one is similar to the one that we just did, only that now the variable that we are finding its value has moved from s to y. Okay, so let's see. 9a, after we've read the question, underline the salient part. Given x minus y is equal to 3, this is your equation 1. And, or you can even ignore the end, comma. Then 3x plus y is equal to 1. That will be equation what? 2. So let's study. we need to find the value of y. And remember what I told you. If you want to find the value of x and you want to use the elimination method, you eliminate y, then automatically you find the value of x. If you want to use the substitution method, you make y the subject. Then you go in any of the equations that you think y made a subject will not involve a fraction or will be easy. Okay. However, if you want to use elimination, the point is eliminate y if you are finding x. If you want to use substitution, the point is make y the subject if you are finding what? X. So in the same way, if you are finding y, okay, you need to make what? If you want to use elimination, you have to eliminate x. If you want to use substitution, then you have to make x the subject and go and substitute. So here, let's see. If I want to eliminate x, I have to multiply this equation 1 by what? 3 before I can eliminate. Okay, if I want to use substitution, okay, if I want to find y, if I want to use substitution, I have to make s the subject. So let me see. S the subject here will not involve a fraction. However, s the subject here will involve a fraction. So I will go for the substitution approach. So I'll write from equation 1, make s the subject. So x will be equal to, okay, y plus 3 or 3 plus y. Then call this one 1a. Okay, then you go and write substitute equation 1a, okay, into the equation that you didn't make x the subject. So your second equation. Okay, so that will give you 3 into your x, which is y, plus 3 plus y is equal to 1. So that gives you come and remove the brackets here. 3y plus 9 plus y is equal to what? 1. So in this case, we are going to get 4y is equal to 9, 1 minus 9, so minus 8. So you write it again before you divide. So minus 8 over 4 over 4. Okay, so that gives us y is equal to, so I can draw my conclusion, minus 2. You were asked to find the value of y. So you don't need x, so don't stress yourself to find x. Okay, so if you are privy to the advice and the instruction that I've given you, always you will stress yourself. So the same, okay, for this one. Okay, with this one, you can easily eliminate x, okay, to find your y, but you eliminate by subtracting because they have the same coefficient. Okay, so the rest basically is the same thing. Take the question to your comfort zone. If you want to use elimination, substitution, now you know. If you want to use elimination, after clearing the fraction and making the equation pretty, you know what to do. Elimination, okay, and you are finding for y, eliminate x. Okay, substitution and you are finding for y, okay, make x the subject. Okay, go and substitute. So that will be it for this set of equation. Okay, so now let's look at the last, okay, set of equations. I think let me look at the question 11. Okay, I am going to do question 11a. If you're able to do 11a, okay, I will do maybe I and I. Or you should be able to do the questions in question, what do you call it? 10. Okay, as well, because this is a little more complex, okay, than the question 10. So quickly, let's do this, and after this, we are done. Okay, so that will give us solution. Okay, so I'm looking at 11, question 11, okay, A. Okay, what am I? I've been given these two, and I was asked to find this. So quickly, let's solve for the A and B so that we can find 5A minus 2B. We are asked to find the value of this. Before you can find the value of this, you need A and B, their corresponding values. So that will come from solving these two equations simultaneously. So that will give us equation. So given our first equation, 2A, okay, minus 1 on 3B, okay, is equal to 7. I won't label it, I will transform it. Remember, it contains a fraction, and in that fraction, your letter is not the denominator, so you can clear. So multiply through by the LCM, this is over 1 over 1. LCM will be 3. Let me write the 3 well. It's looking ugly. Okay, so now this is over 3. Okay, so I will multiply through by 3. This by 3 will give me 6a. This by 3, the 3 will cancel, so I'll get minus b. I won't write the 1. It's simply understood. This plus 3 will give me 21. Okay, so at this point, I will call this equation 1. Okay, then go to end. Your second equation, what do we have? A, okay, plus 3b, okay, minus 10 is equal to 0. So, okay, I want to maintain, okay, the letters here and take this one to this side. So I'll write this implies that I'll transform it 10. So I will call this equation what? Equation 2. Okay, so now this is what I'm going to do. Okay, here you are at liberty to use any of the methods. You are not looking for A, you are not looking for only B, you are looking for the two of them. That will help you to find the value of what you have there. So at this point, let me see. Okay, I will go for substitution method, okay, because I can make A the subject here and it will not involve any fraction. Equally B the subject here, it will not involve a fraction. Okay, so at that point, if I knew my plan, I wouldn't have labeled this equation 2. But I've labeled that already. I don't want to cancel. So I'll go and write from, okay, equation 2. I will get A to be equal to what? 10 minus 3b. So I will call this equation 2a. Okay, then go and write equation 2a into the other equation. So into your first equation, which is equation 1. So that gives you 6 into a, and a is 10 minus 3b. Okay, and minus b is equal to what? 21. So what do? I am going to get, this time this will give me 60. So 60, okay, this time this will give me minus 18b. Minus b is equal to 21. Okay, so that in effect is going to give us what? Okay, this and this will give us minus 19b is equal to, and you are going to get what? 21 minus what? 60. And we all know that, no, it will be, yes, 21 minus 60. So we are going to get 21 minus 60 will give us, okay, minus 39. So you get minus 39 here. Okay, you write it again before you divide. Okay, 19b minus 19 is equal to minus 39 over 19, minus 19, sorry, over minus 19. Okay, so that gives us what? Okay, so that gives us, hello, my professors. I think at this point I can, okay, you can be on your own because my point is well made. Okay, so let's check whether there is something wrong. Okay, the answer is not looking that pretty, but that doesn't mean you should always get a pretty answer. So 60, okay, minus 18b minus 9. Okay, did I say minus b is equal to what? 21. Okay, and this came from 3 times 7. Okay, so we are right from that step. Okay, so let's see. This will give us minus 19. Then 21 minus 60 will give you minus 39. So that's correct. Okay, so this will give us exactly what you have there. It's not that pretty. So maybe our b will be equal to, so in effect we are going to get, okay, b to be equal to this 39, okay, on, okay, 19. The negative will cancel. So you use this one to find your b. So you go and call this equation what? Equation 3. Okay, so equation 3 into the equation that you made, a the subject. So that is equation 2a, comma, and that will give us a will be equal to 10 minus 3b. So 3, what is your B? Your B is what? 39, okay, over what? 19. Okay, so you know what to do here. I think I can make my point because of time. Okay, so assuming maybe, I'm just assuming you had A to be equal to maybe 1 on 3. So I will now come to I. Okay, therefore, what was I asked to find? 5A minus 2B. Okay, will be equal to 5 into the A. Okay, I said assuming A gave us this. So 5 into 1 over 3. Okay, then minus 2 into B, and B is what? 39, okay, over 90. Then you come and simplify. Okay, then you've already drawn your conclusion here. You are done. Here you cannot conclude with A and B. You can't write therefore A is equal to this and B, because A and B are means to an end. So it's here that you draw your conclusion. The direct question will be this one, and that one. So I guess my point is well made. If you watch the video and you are not able to relate, okay, please, okay, go to the comment section, then type your comments there or your question there, okay, on YouTube, and I'll comfortably go and, okay, give you your response or the response. So at this point, thank you very much, okay, for your time and your attention. God bless us all.